Good afternoon. Thanks for coming to week 6, and we're all happy that next week we'll have a study break. And so today we won't have a very long, lengthy class. So let's hope we can finish it on time instead of being late many of the times. Okay, so last week we have shown you how to draw UML diagrams, but we focus on the diagrams that shows behavior. Okay, for example, activity diagram, use case diagrams, and sequence diagrams. So those correspond to how the system behave and how one internal component send messages to another internal component, from one object to another object. So that is very important to give us like the dynamic behavior of a system. But today's we're focusing on the structural side, which is also important because when you come to think about it, you need to build objects. Perhaps sometimes you need to group several objects together and make it contain in one place, like put a container around several objects. So we may need to group things together to give it a structure. So this is how we write programs. So both are important. So this week we'll focus on the structural part. Okay. For beginners, sometimes we have trouble finding out what classes are out there, what tasks do they do, what other objects do they work with. So we'll introduce a game called CRC cards, okay, to help us identify classes and what they do. And if we want to name one type of diagram that is most important, like one structural diagram that's most important in UML, it will be the class diagrams. So this is, let's say if you forget about the other diagrams I'm showing today, remember you need to know class diagrams. And object diagrams is a variation of class diagram. Class diagrams show us the general picture. It's almost like templates. But object diagrams show us some actual instances created from the classes. And CRUD analysis, CRUD stands for create, read, update, and delete. And I'll show you how to use this technique to help you make sure that you don't forget any important thing. In project management, one common problem is that we forgot about things that we need to do. So we fail to allocate time for doing that task. So that's how we, the projects behind schedule, because we forgot about doing things. And finally, we'll discuss two concepts called coupling and cohesion. And we use them as our criteria to decide whether an OO design is a good one or a bad one. Okay. But so let's remind ourselves with some terminologies. Last week we talked about structured analysis, which people use before we have OO. So what do people do in structured analysis? One of the things they do is called functional decomposition. And it means at the beginning, they decide they need to have several big functions. And then each big function, they divide it up into a few smaller functions. And so that's why we call it top down, because at the top, one system is seen as a big system, then divided into a few big functions, and each function is broken down into smaller functions. Do you recall that we have learned anything similar to that functional decomposition so far？ 我哋教咗未呢？好似未教係咪？breakdown structure 我哋未教嗬，我哋未教 breakdown structure。Okay. But the idea is one thing, you continue to divide things up until something is small enough and manageable enough. Okay. And how do, if people ask you to explain what's the difference between OO and non-OO, okay, so how can you explain that? I can imagine 20 years ago when you go for a job interview, that will be a very likely question people ask you 20 years ago, what is OO? But perhaps today, employers come to expect you to know. So since most people know, they probably don't ask you about that question in the interview. But it's still good to know. So OO consists of inheritance. Inheritance is child class and inheriting from parent class. So that's inheritance. But another thing is called data encapsulation. The word you may have heard of capsule. Have you heard of the word time capsule? Time capsule, 時間囊. Okay, capsule, CAPSULE. It's something you put things inside. So it's a capsule. So you try to enclose things inside. And one very important idea in OO is you enclose data and the operations together. In the old time, in structural analysis, data and operations are sort of separate things. So programs are difficult to write and maintain. But OO try to keep them together. So we first think of data, we first identify what data we need. So we group related data together, and then we think of operations that you work on the data. And people are not allowed to get at the data directly. If people want to get at the data, they have to get it through those method. Okay, so whenever you want to get some data in from an object, you have to call the method. Even if the language allow you to access the data variables inside an object, the attributes, but you're still, for good programming practice, you still should not do that directly. You should get through the operation. And the benefit is you have a program calling another program, one object calling another object. As long as the interface does not change, the interface of the operation. What is an interface? An interface is the name of the operation and also the parameters and what it returns from the function. If you keep the interface unchanged, then you can change the caller and the callee. Someone who's calling, who's being called, they can each change, and the program, the resulting program will still work as long as the interface between the two is the same. So that's how we achieve software maintenance. Maintainability. So a class. So what do we have inside a class? Well, first let's look at an object. An object has some data and operation. And a class, you can think of it as a template. So you can use this template to create objects. Okay. So one object and another object, for example, student is a class, but different student can have different names. So Alice is one student, Bob is another student. So these are the Alice and Bob is different objects, and they have different attribute values, but they share similar method. For example, you can enroll a student in a course, so the method will be the same. Okay. For example, bank account. Bank account is a class, right? And all the objects may have the same methods of deposit, withdrawal, and so on. But every object has its own balance and own account number. Okay, so that's the relationship between class, which is basically a template, and object, which is the actual instances. We have seen this last week, and last week we discussed activity diagram, use case diagram, sequence diagram, and very, very briefly communication diagram. Today we will look at class diagram, object diagram, and package diagrams. So what kind of objects can we have? It's really up to us to decide. They can be physical objects, or they can be virtual objects that we come up. So what are physical objects? For example, in an inventory system, you have some products that you're selling, you're keeping in the inventory, but you can also write a class to represent a product class. But what is virtual? Do we have virtual objects in an inventory system? I guess something we can imagine. For example, product, originally product does not have an ID, but to make it easier for us to identify, to differentiate different products, product description is too lengthy, and sometimes there is a risk of duplication. So we invent some new entity called product ID. But product ID is probably just, we will use it as an attribute. We won't use it as an object. Product ID is not big enough to be an object. Okay, but product is an object, but not product ID. Product ID. So now we have we need to create a system. So how do we identify different objects? Some people invented a game. You can think of let's see what CRC stands for. It stands for class, responsibility, collaboration. Responsibility is what I do. Collaboration is what I do things with. Like, for example, who are helping me to do this task. And of course, I have a name. So these two guys create this brainstorming tool that people, a small team of people, 1 to 5 people, typically, they each will get a card and then pretend they are a particular class. Okay, but let's introduce these two guys. Watt Cunningham, he invented this framework for integrated test, which is a very highly automated testing tool that can you can use it to test another software. Okay, so you can write your test using a spreadsheet. You describe your test on a spreadsheet, and you can run the software, and it can test a piece of software. Even to the level of using the user interface. Okay, so this is a very interesting way of doing things, and some of my previous students did a FYP on this. Okay. And Kent Beck is even more famous. He invented extreme programming and test-driven development. Okay, we would learn about test-driven development when we learn testing later in this course. And the two of, I think, not just Beck, but Cunningham too, about 16 years ago, 17 people get together, and together they signed the Agile Manifesto. Manifesto in Chinese means 宣言. Okay, so together they declare that they are not happy with the way software is being developed and software project being managed by someone who don't even write code, so by some managers. Okay, so all of them are programmers. Okay, but they're all very smart programmers. They can communicate, they talk to customers, and also they can do project management and many other things. So it was 16 years ago that they make this movement, which now the Agile movement, including the Scrum method that we learned, was result of this Agile movement. Okay, but first 5 years, I guess big company don't care about it. But then roughly 10 years later, then more and more company care about it, and then now almost you cannot find a company that does not make use of some Agile method one way or another. So almost all companies use a little bit, even though they may use it under a conventional software development house, but they still they borrow techniques from Agile method. Okay, now the two of them invented CRC card. CRC card are actual physical card, 4 by 5 inch, and then they write down the class name. Okay, suppose in a system they have person class, and it has the data attributes and the method names. You would put it in the responsibility. For example, the gender of the person, male or female, how old, and also methods. For example, the age calculation and what does it do. I guess they try to make it fun to say it's cook. Of course, in a computer system, we don't. Oh, but maybe this is a cooking system. So, and in this cooking system, it has some recipe classes. Okay, and there's also cuisine classes. So, cuisine could be Chinese cuisine, Northern Italian, Southern Italian, or even within Chinese, there may be Sichuan, Cantonese, and Shanghainese, and so on. But under each kind of cuisine, there are different recipes. Okay, for example, gongbo gaiding and something like that. Okay, so the same collaborators are other objects, other classes. Responsibilities would be action. Okay, usually is action. For example, calculate. You can think of it somewhat like the use case. Use case start with an action verb. So these responsibility mostly, except unless it is a data attribute. Otherwise, it should also start with an action verb. So these people would each may hold 1 or 2 cards, and then they write down who they're responsible for, and then use narration. So I would say, I have this responsibility, I have this responsibility. I use your service. So another person may be holding the recipe card, and then what do you think a recipe card class would have as responsibilities? Okay, the data side could be ingredients, right? A recipe would have ingredients, and then the action part would be perhaps instruction, how to cook, step 1, step 2, step 3, and so on. So a recipe would have its own responsibility. And since person is a collaborator of recipe, probably recipe would also be a collaborator of person. So each person, they get 1 or 2 cards and they role play. They pretend to be that person. And then through discussion, each person would focus on thinking on what that class should do. So and in OO, I guess because right now using Java or C++, one objects, when they need the service from another object, we say it called a method. But in the older days, I think I have asked you this before. What is the first general purpose OO language in 知唔知道啊？有冇人知道？我可能應該講過。Small talk 有冇少少印象？有冇聽過我講過呢個字啊 ？OK，small talk 就係一個就係而家公認嘅第一個嘅 OO language 咧，係 actually 係叫做 similar。OK，similar 咧係 SIMULA。係 simulation 嘅頭一部分。咁 similar 咧就並唔係一個 general purpose 嘅 OO language。similar 咧係一個要嚟咧當係 mimic 啲 physical objects 嘅 programming language， 好舊㗎啦，即係可能有30-40年㗎啦。咁但係後來咧，啲人就發覺其實 OO 呢一樣嘢，除咗係做 simulation， 即係當係有張台、有張凳呢啲咁嘅即係真實嘅公仔之外咧，其實原來都可以要嚟用喺 general purpose 嘅 programming 嘅喎。咁所以咧佢哋就有人就諗咗個叫做即係 small talk 嘅 language。OK， 咁而 small talk 咧佢個 language 咧，佢哋用嘅 terminology 咧就叫 send message， 即係話當一個 object 需要另外一個 object 去幫手嘅時候咧。佢哋 instead of 叫佢 call 佢嘅 method 咧，當其時咧佢哋用個 terminology 咧就係 send 嘅 message。咁即係話，譬如果我想做5+2咁先算啦，做呢條數咧，咁咧喺 small talk 入邊咧，個5咧個 number 咧係一個 object， 個2係一個 object。咁咧佢會做嘅一樣嘢咧就係咧個5個 object 咧就會send 一個加嘅 message 俾個2。咁然之後個2咧就 return 翻個 function。咁 that's how 呢個即係 terminology 咧，即係如果你睇一啲可能比較 pure 啲嘅 OO 嘅書啊書籍嘅時候咧，佢哋有時會講話 send 呢個 message， 就係因為多少係因為受 small talk 嗰陣時嘅影響。咁但係而家即係一路咧，即係隨住先有 C++ 啦，後有 Java 啦。咁而家再加上而家後來所有新嘅 language 啊，基本上全部都一定有 OO 啦。咁嗰陣時即係依家就開始，我哋就轉翻用翻以前嗰個 terminology， 即係所謂傳統啲嗰個叫 call 個 method 啊咁嚇。即係曾幾何時咧 ，OO 咧就係用個 send message 啊 receive message 咁樣嘅 terminology。OK， 咁所以嗰陣時，如果佢哋做 simulate， 即係佢哋做 role play， 即係做戲，即係每一個人扮係兩個 class 咁嚟去做嘅時候咧，揸住兩張卡嘅時候咧，佢就會話：我 send 個咩 message 俾你啊咁樣 ，instead of 我 call 你個咩 method 咁透過 Agile methods 嘅人咧，其實佢哋都係佢哋做嘅嘢都係幾互動嘅，所以佢哋好似個 estimation 嗰個 poker game 嗰個 estimation 嗰個 game 咁樣啦，之前教過，即係佢哋都係嘗試係用互動嘅形式啊 game 嘅形式咁樣去做。咁而家呢個 CRC 係亦都係咁。Martin Fowler， 其實我唔肯定 CRC cards 係咪 Martin Fowler 即係諗出嚟嘅。咁呢幾個人咧，譬如 Alistair Cockburn 同埋Martin Fowler 都係即係都係Agile methods 嘅啲表者嚇，即係Alistair Cockburn 佢寫過一本好出名嘅 use case 嘅書嘅。咁 Martin Fowler 有寫過一本好出名嘅code refactoring 嘅書，咁同埋佢亦都寫咗有一本domain specification language 嘅書，咁呢兩個佢都即係都係好有影響力㗎啦，即係喺個 agile 界入邊啦。OK， so let's look at this building block of a class diagram. So if you see later, we'll have class diagram like this. Okay, this is a complete class diagram. But first, let's look at each building block. For example, this is a person. So let's see what it has. For example, in a bank account, we use a 3-compartment box to represent a class in a class diagram. So the top compartment, we put the class name. The middle compartment, we put the attribute names. Okay. Sometimes you can also put the attribute type. So these attributes are owner and balance, and the data type is string and dollars. But of course, you are not required to put the data types here because as we said again and again, in modeling, there's not a fixed rule of how much details to put in. Okay， 譬如如果你覺得我唔需要咁 detail 啦，我可能淨係俾個名，唔需要俾個 data type 都得嘅。OK， 咁又或者我想再少啲咧，就係我淨係俾個 class name， 唔擺呢啲嘅 data attributes， 或者唔擺呢啲嘅 method， 都即係喺個 class diagram 嗰度咧，有時都可以係絕對係可以接受嘅。當然，除非喺條考試嘅題目嗰度，有時我會俾啲additional requirement 話你一定要俾3個 data attributes， 2個 method 俾我咁樣。咁呢個係嗰條題目嘅要求啦。但係即係喺實際上用嘅時候咧，你可以話係可能開頭嘅時候咧，我哋就咁有一個 class diagram， 淨係有個 class， 淨係需要畫咗呢啲 class 個 class name， 呢啲係遲啲去加，又或者咧有啲人可能佢索性會 skip 咗喺個 modeling 嗰個 part 擺呢啲嘢，直接去做 coding 嘅時候先至喺個 code 嗰度加翻落去。咁點解咧？就係因為其實我哋又講翻 Agile 嗰個嘅個主要嗰個 principle 咧，就係咧佢哋唔中意嘥時間去做 documentation。咁佢會覺得，咦，我嘥咗啲時間畫個圖，如果擺晒呢一啲嘅 information 喺呢度嘅時候，會唔會索性我將啲時間擺喺 code 嗰度仲好咧？咁呢個有可能嘅喎。同埋咧，你哋諗唔諗到？如果我問你如果我將所有呢啲嘅 detail 都放喺嗰啲 documentation 嗰度，有冇咩嘅 potential 嘅危險或者唔好嘅地方啊？有冇諗到啊？嗱，有一樣咧，成日有機會發生嘅，即係呢啲我哋見好多咧，就係咧，當個 system 開始做嘅時候咧，所有人咁嗰啲 designer 做晒呢啲嘅 documents 啦，好 nice， 咁然之後咧，到 programmer 就揸住呢啲 document 去做 coding， 咁你又覺得啲 effort 都應該都唔係嘥咗好多嘅 ，OK？ 咁但係可能到某月某日 啲 programmer 會改個 program 嘅時候咧，10個 programmer 有8個都唔會記得翻去改翻啲 document 嘅。咁所以咧，久而久之咧，當個 program 一路改嘅時候咧，嗰啲 document 咧就一路越嚟越 out of date。咁呢一個咧係一個嘅，即係對於 software development team 啊、software maintenance team 係一個問題嚟㗎啦。咁所以有可能將來要 update 嘅時候咧，又好嘥時間啊咁。咁所以呢個係一個 trade off 嚟嘅。即係如果啲所有嘅嘢係準嘅話，當然我諗睇一幅咁樣嘅圖，呢度係容易過去睇幾千行曲，抄翻嗰幾十行即係相關嘅行出嚟啦。OK， 咁所以有時其實究竟做 modeling 做到幾 detail 啊？呢啲為之係最理想咧，係好難係有一個嘅即係好yes no 嘅 answer 嘅。即係有時咁，所以我只係話咗俾大家聽咧，即係 agile 嘅人咧就傾向就放少啲 detail 喺個 model 嗰度，就多啲放佢啲時間就係齋寫曲。咁但係 conventional 嗰啲人咧，即係就多數係會可能會 insist 佢係即係 development 嘅時候啲 documentation 要做到齊晒啊咁樣。OK， 咁呢個係一啲嘅唔容易嘅，即係咁當然你 you have to go with whatever company philosophy that you're working for. OK， so and now this is that again. Top compartment is class name, middle is data attribute, bottom is operation. And we can also use plus, minus, and the pound sign to represent the accessibility of the data attributes and methods. In the early days when we are new to OO, lots of people are still undecided whether data attributes should be private, public, or protected. Okay, but today I guess almost everyone would say you must not use public data attribute. Public 嗱 public 嘅意思即係話咧任何人都可以睇到嗰個 attribute 或者 operation， 咁嗰個就叫 public。咁再收窄少少咧，就係 protected。protected 就係所有嘅 child classes、grandchild 啊之類咧都可以睇到嘅。OK， 咁但係最 most restrictive 咧就係淨係嗰個就係 private， 就淨係嗰個 object 先至可以見到。咁而家嘅我哋嗰啲 data 即係基本上全部都係會覺得係值得係 private 或者係 protected 啦即係唔會再有人用 public。咁而 operation 咧我就會傾向我大部分都係擺即係我都係唔理嘅，都係public 啊咁樣。咁除非你覺得有足夠嘅理由，咁你可能想用 protected 或者用private 啊咁樣嚇。咁但係如果用 protected 或者用 private 咧，即係話你用嗰個inheritance 啊嗰啲係用得好犀利咯。即係其實如果講翻 OO design 咧，其中有一樣嘢咧就係OO design， 你會覺得如果一個 parent class， 即係你要用一個 class，parent class 有 child class 有 grandchild 有 grandchild。你會覺得咁樣去睇一個 library， 即係對你嚟講容唔容易去明白，容唔容易去學啊嗱 ？OK， 其實有時都要花啲時間㗎。咁所以即係如果我用一個咁嘅 class library 咧，基本上咧你係要用熟某一個嘅 class library。即係如果你係想要轉 class library 用嘅時候咧，係一個都唔如果我係嗰個 class hierarchy 係好 deep 嘅，即係好多層嘅話咧。其實係增加咗個難度，咁所以其實我諗我自己係好個人咧，我自己其實亦都有部分其他嘅人咧，都唔係特別中意 OO 嘅一個好即係 好 deep 嘅 hierarchy 嚇，即係我哋正話都有講過啦。如果人哋問你 OO 係包括啲乜嘢，叫你用2個字，即係用2個 concept 去描述乜嘢係 OO， 咁你可以話俾人哋聽咧。第一個咧就係 inheritance 啦 ，OK？ 呢個 inheritance 就係有subclass 啊咁樣係可以幫助我哋嘅 reuse。咁另外嗰個咧就係 data encapsulation， 就係 data 同埋 operation 咧係捆綁埋一齊嘅，即係我哋唔可以即係拆開佢嚟用啊。咁如果你想要啲 data， 你就一定要係透過啲 operation 去攞。咁但係以我自己個人嚟講，或者有某一啲嘅 computer scientist 咧，佢哋就比較即係中意 data encapsulation， 覺得嗰個嘅貢獻啊或者嗰個嘅益處咧係比較大啲，而個 inheritance 咧就可能係見仁見智啦啊！即係有時可能有啲人會覺得可能會濫用咗都唔定，即係話啲人咧就係整到改少少嘢咧，又整一個 specialization， 改少少嘢又整一個 specialization 咧。就搞到你要去明白一個 class 嘅時候咧，你要抄晒佢祖宗18代嘅時候咧，即係我諗我哋識朋友嘅時候都想就係淨係識呢個朋友就了解呢個朋友就算啦。如果你要識埋佢阿爺阿嫲啊嗰啲咁樣，好複雜啊。咁所以當然見仁見智。咁有一啲 OO 嘅人咧，佢就會覺得class hierarchy 係好緊要 ，inheritance 係好緊要咁樣嚇。咁但係咁我都冇反對嘅。但係嗰個即係個 drawback 就係話，如果係咁嘅時候咧，係你影響住你唔可以識太多嘅 class libraries 咯。即係你識太多嘅 class libraries 咧，可能你都記到亂啦嚇，好複雜啊咁樣嚇。Next, in the class diagram, we draw a line between two classes to show association. So to mean this is related. And so, for example, if we want to represent a company having several persons to work in it, then we may draw a line here. And equally useful is the multiplexity. The word multiplexity, if in database terminology, is called cardinality, okay? But I think they should mean the same thing. At least I don't know the difference between the two. But cardinality is used by the people who draw ER diagram. And multiplexity is used by people who draw a class diagram. So this means a person only works for one company. But so by going there, there's a 1 here to mean each person can only have one company. But when you follow it to this end, you see that a company can have 1 or any number of persons. Okay, so there's no upper limit of how many people. If you have 100 persons, you can hire 101, 102. If we have 1 million, you can have 1 million and 1 million and 2, and so on. So multiplexity, I would say, is very useful in a class diagram because it changes how we write the code differently. Okay, 相反即係反而呢一啲嘅 detail 咧，我會覺得可有即係視乎我哋想要幾 detail operation 或者 data attribute。如果你想要嘅，咁你就加咯；唔要嘅時候，即係都唔係太緊要。但係個 multiplexity， 我自己就覺得係非常之緊要啦嚇。咁有唔同嘅寫法啦。呢度有寫譬如0或者1啦，甚至乎你可以，如果你寫緊嗰科係你寫緊嗰個係大學嘅 registration system， 一個同學可以讀你想 specify 係0至5科嘅，咁你咪可以喺呢度寫0.5咯嚇咁樣。但係 star 咧就係代表即係幾多都得嚇。咁我哋 take 一個 short break， 然之後繼續。